Okay, so today is day 7, and it's actually, this is over samples and surveys, and we split it into 2 different parts. So day 7 and 8 are the 2 parts. Our learning target is, I understand that I can get a good statistical representation of a population by studying a sample of that population. I can identify sampling methods, and I can recognize bias within samples and surveys. So, imagine you are making soup, okay, for a gathering. There's people over. I know a lot of you probably do this. You have friends over, you make soup for them. You know, what high schooler doesn't do that? And you want to test it to see if it tastes good. How would you do this? Okay, so if you want to just check it out and see if it tastes good, would you need to eat the entire pot of soup to see if it tastes good? And do you think it's a good idea to stir it first? You know, say you're making the soup and it's on the stove, it's been cooking for a while. Do you skim the surface and take a bite of that, or should you stir it up real good and then take a little bite? So of course, you know that yes, you could sample a spoonful. So I would just take one. I would sample a spoonful after stirring. Okay, so it's kind of what we want to do when we're taking a sample of a population. Okay, we want to stir it up. We want to make sure that it's not just one group of, don't want to select just from one little part, like the top of the soup or in the bottom of the soup. Maybe it's potato soup. You don't want to just select a potato chunk and eat that and see if it's good. You want to stir the whole thing up, take a spoonful. So a blank is all those members of a set. Okay, so a population. A sample would be a part of the population. So that sample could represent it if the sample is collected correctly. Okay, so if you collect it correctly, it'll represent the population. So if you're trying to figure out what percent of high schoolers like Pepsi, well, I could take a sample of 20 students. If I do it right, I'll get a pretty good idea. If 78, if you did 20, so 75% of them like Pepsi, it's probably a pretty good indication that 75% of the whole high school likes Pepsi, if you collect it correctly. So collecting correctly is the hard part. So we got to figure out how to stir up the soup, how to do it correctly. Okay, so below here are some types of sampling. Some are good, some are bad. Okay, and we're going to go through them all. Okay, so let's go through these. Again, there's 4 main types here. And in each one, we're going to decide, is this a good or a bad? So is this, and when we say good, we mean very little bias. Then if we say bad, that means it potentially has a good amount of bias and it should not be used. And bad meaning it will not represent the population if you do this. Okay, so the first one, it's called a convenience sample. And it's the idea is that you choose individuals from a population who you can easily reach in the moment. Okay, so like the example I give is I would like to sample a group of high school students to represent Homestead. So I asked the 25 students in my 4th period math class. Okay, now do you think that the students in my 4th period math class represent the entire population? Well, if you think, whatever that subject might be, whether it be Algebra 2 or could be calculus, could be Algebra 1, whatever it is, there's typically a certain age group that takes certain classes. Algebra 2 is typically a sophomore or junior class. So if you're outside of that, we're not going to tease you about it, but it's typically a sophomore or junior. So it's not really that good of a sample because there's going to be a lot more sophomores and juniors represented in the sample, and freshmen and seniors are really going to be represented, well at least. So this one is not good. A convenience sample is not good. So we'll say bad. That's a bad one. Rarely is a convenience sample a good representation of the population. So again, just getting individuals who are easy to reach at that time. So you're quickly trying to get some results. Let's see here. Self-selected sample. So self-selected is only people in the population who volunteer are included. So you have to volunteer yourself. You self-select yourself. So I'm wondering if my students like my teaching style. So I send out a link to all my students, asking them to respond whether they like my teaching style or not. Now, for the most part, who's going to answer? Who's going to respond to that survey? If you're kind of like, he's all right, it's okay. You're probably like, I'm not going to waste my time answering. But if you feel really strongly about it, really strongly, good or bad, boy, I want him to hear, I hate his teaching style, and I'm going to let him know about it. So you'll respond. You're much more likely to respond. Or if you really like the teacher, boy, I love that teacher. I want them to know how good they're doing. So you're going to get the people with strong opinions, pretty much only. Another example of this is like on news, sometimes on the evening news. If any of you watch the evening news anymore, I don't. I used to when I was a kid, but I don't watch anymore. But they'll put up a survey, a hotline. Call this number and tell us what you think. Well, only people who have a strong opinion are going to call that number. So you're not getting a good representation of everyone. You're only getting the people who have a strong opinion. So this is also bad, meaning bias. There's going to be bias in that. Systematic is ordering the population in some random order and then selecting from it at regular intervals. You follow some rule of thumb, like you're going to take every 5th person, every 8th person. You're going to follow some rule to get regular intervals of people. So let's say I want to know what percent of the population at Homestead prefer Pepsi to Coke. So I get a complete list of all the students from guidance. I alphabetize them. Now, is that random? Yes, because when you were born, there's a random last name was basically assigned to you when you were born. And then I select every 15th student on the list, and I ask them which they prefer. Okay, so this one, every 15th person, it's all mixed up. We put them in random order, and then we selected, at random, basically, every 15th person. That should represent the population. Okay, so more likely than not, that's a good sample. So convenience bad, self-selected bad, systematic good. And systematic just means you follow some sort of rule where you ask every 10th person, every 15th person, every whatever rule you're following. And then a random sample. Okay, a random sample. So all members of the population are equally likely to be chosen. There's a couple ways you can do this. Okay, so like one way, I want to know what percent of the teachers at Homestead are satisfied with their job. So I assign each number a unique number from 1 to n. Let's say there's 100 teachers here, so from 1 to 100. There's a lot more than 100, being the number of teachers. I use a random number generator, it's like my calculator, to generate 30 unique values. So there's no repeats from, say, 1 to 100. So if there are 100 teachers, I pick 30 random numbers. They're unique, so there's no repeats in them because you don't want to ask the same teacher twice. I survey the teachers whose names correspond to the numbers that were generated. So if I assign a certain teacher, just pick a teacher, the number 5, and that number 5 is one of the randomly generated numbers, then they get asked the question. So everyone had equal chance. Okay. Another way to do it would be write each teacher's name on an equally sized piece of paper and put all of them into a container, mix them up real good, and then just draw 30 papers out. I survey the people whose names were drawn. So that's another random sample. That's a version of a random sample. Okay, now this one, everyone had an equal opportunity, so that should represent the population. That's good. That's a good one, a good way to survey. So systematic and random are good. Convenience and self-selected have bias. So they're not very good. Now, could these have bias? Yes. Systematic and random may have bias. What if the question was, something that gender would make you more like. So if I say football, what percent of all the teachers at home said like football? And I did a random sample, and all 30 people I chose were males. Well, males are probably more likely to like football than females. So now it was accidentally biased. So it's possible, but these most of the time are not biased. These typically are biased. Samples can vary in how well they represent the population. That's what we're just talking about here. Like a random sample could, but most of the time it'll be a good one. You want to select a method that limits bias. You can't eliminate it completely. There's always going to be something. There's always going to be, even if you do the best method you can, you may accidentally have some bias within the sample itself, just because the people you selected, like, whoops, all those people have this in common. Now it's bias. So bias is when part of the population is either over-represented or underrepresented. So you don't, if I want to survey the whole high school, I don't want to get mostly freshmen, because then freshmen will be overrepresented, and then sophomores, juniors, and seniors are underrepresented. Okay, and we want everyone represented equally. Okay, so let's flip this paper over, and I'm going to cover. Actually, I have all my answers written out, so I'm going to cover them up. Maybe like get a different sheet of paper. So it's confusing. Okay, so let's do this. I'm just going to roll back my paper, so you have to watch me write it. So a newspaper wants to find out what % of the city's population favors a property tax increase to raise money for local parks. For each of the following, which of the sampling methods what is a sampling method? Which one of those four? And does the sample have bias? Explain. So a newspaper article on the tax increase invites readers to express their opinion on the newspaper website. So you just log on and tell us what you think. Okay, so which one is that? Okay, so this one, out of your four, you got convenience, self-selected, systematic, or random. Okay, so this one would be self-selected. They decided themselves. So it's the self-selected. Is there bias? Yes, there's going to be bias, because the only people that are going to respond are the ones that have very strong views. Okay, so typically most people like taxes. I don't love taxes. I think there is a need for some of them, but sometimes they're silly. And some of the ways government spends money is silly. At least I don't agree with it. But other ways I do agree with it. Education, for example, I agree with. I think we all should have. So people typically about taxes have strong opinions because it's their money. How about instead, a reporter interviews people who are leaving the city's largest park. So as they're leaving, they come out, they walk up, and they ask them, like, hey, what do you think about this? Okay, so what would that be? Which one of those four? So it sure seems like this reporter is just trying to get some opinions. So this is definitely convenience, because they went to a park, they know they're going to find people there, they ask them questions. Okay, so is it bias? Yes. I'm not sure why I started circling no on this, but yes, it is bias, because if you're leaving a park, you are probably like parks and would be like, I don't mind tax dollars being spent on parks. Okay, so that's definitely a reason why convenience would be so biased. How about C, a survey service calls every 50th listing in the local phone book. Okay, so every 50th listing in the phone book. So phone book is alphabetically arranged, and you're going to follow a rule, call every 50th person. That sure sounds like systematic. Okay, so is it biased? Well, no, it's very limited. So bias would be limited because everyone in the phone book has an equal chance. You do want to keep in mind, especially today, in the last 10 or 15 years, people have stopped having landlines and they don't put their number in the phone book. So anybody who has just a cell phone and their number's on the phone book, they are excluded. So there is some bias. You can't avoid bias. I mean, it's really very difficult to do. You'd have to somehow find, the contact information for everybody in the city, and then pick every 50th person to fully eliminate, not even fully eliminate, but eliminate a little bit more. But it is systematic, so it's very limited. It's not that there's no bias, but it is very limited. Okay, for each of the following, what is the sampling method, and does the sample have bias? Explain. So just no more park. So it's a whole new question here. For each of the following, a supermarket wants to find the percent of shoppers who use coupons. So the manager interviews every shopper that enters the greeting card aisle. So basically, he's going to go to the greeting card aisle, and he doesn't want to move. He just wants to sit in one aisle and talk to everybody. Okay, so which kind of sample is that? That's convenience. It's kind of being lazy. Is it bias? Yes. Not every shopper even enters the greeting card aisle. A large portion of the population are excluded. Okay, so the population being all the shoppers, a large portion of the shoppers are excluded. So that was the only people who go to the greeting card aisle. So do greeting card people who are buying greeting cards more likely to have coupons? I don't know, but you want to catch everyone. Let's see. So a high school this is a long one. Typically the longer one means it is good, but A high school, not all of them, a high school with 150 seniors wants to find the percent of seniors who plan to attend college. A list of every senior is obtained, and each student is assigned a number from 1 to 150. We use our calculator to randomly create 30 unique numbers. The students whose numbers correspond to the numbers generated are asked, and the results are recorded. Pretty detailed. Everyone has equal chance because they're all of them, the entire group, and we're going to select 30 random ones from that group. So that is random. Bias, again, limited, so no, very limited. So every senior has an equal opportunity to be selected. So the sample should represent the population, which in this case is all seniors. Okay. So hopefully this helps. Just remember, it's those four. It's those four kinds of what you're choosing from right now. So the four types of sampling.